Myself, Dr. Pratibha M.K., Associate Professor, ATME, College of Engineering, Mysore. Today I am going to explain 4th semester Microcontroller lab program to separate even and odd element in a given array. So before writing the program, you have to know how the microcontroller works to separate even and odd number of an array. So let us consider an example of a number. So in this, let us consider a numbers example odd numbers. 81H, 97H, 2 and then 2BH. 81H can be represented equivalently in 10 form 100000. Similarly, 97 is nothing. B is nothing but it can be represented as 8 plus 2, 10, 10 plus 1, 11. So in all this case, you have observed that the least significant bit B0 will be equal to 1. Significant bit B0, B0, B1, B2, and this one is 8 bit is used to represent the data. So in this B0 for odd number, it will be equal. Similarly consider an even numbers. So for example, 64H, 62H, 0. A is nothing but equal to 10. Its equivalent BCD code can be represented by 8 plus 2, 10. So if you observe in all this number, the least significant bit is equal to 0. So if the B0 equal to 0, this should be an LSB. If the B0 equal to 0, then this is not MSB, this is LSB. If to 0, then it is an even number. So in order to check the status of bit LSB, in order to check the status of bit LSB, we have to use the rotate right instruction. We can use the rotate right instruction. So whenever you rotate using a rotate right instruction through carry, so you will get B0 to the carry flag. So by checking the carry flag, we can decide whether the given number is odd or even. If the carry flag is 1, we can decide the tested number is, the checked number is odd number. So respectively, we are going to increment the counter. So these are all the different registers used in this program, whereas R0 is used to hold the even number count and R1 is used to hold the odd number count, and R2 is used to hold the length of the array. Whereas DP, how many number or how many data are there in a given array. Array is nothing but it can be defined as a successive data is stored in a memory. So DPTR is nothing but it is used to hold the starting address of an array. A sequence of data is stored in a memory location is called as an array. So in this example, I am giving the 7 numbers, 7 data. So if you observe this, 45 is an odd number, 87 is an odd number, 15 is also an odd number, 90 is ended with least significant bit equal to 0. So that can be considered as an even number. 89 is also odd, 23 is also odd, 46 is also even. So if I count that, how many even numbers are present? 2 even numbers are present and 5 odd numbers are present. So after execution of a your program, you have to get the number of odd and even numbers given in an array. You have to get the count. Okay, this is about the working of an 8086 program. Sorry, 8051 program. So let us consider the program. So the program start with initializing R0, R1 and then R2 to an appropriate value. That is, R0 and R1 is used to hold the count of even and odd numbers respectively. So initially it can be loaded with 00H, or in other words you can represent the 00H also simply by using an hash and 0. And R2 register is used to hold the length of the array. So for this particular example, I am giving 07H. And in the program logic is like this. For each element in the array, is checked by checks the LSB bit by using the instruction RRC through carry. Okay, so this is nothing but least. Okay, by using the instruction RRC, the content of accumulator content will be rotated right through carry. If B not equal to 1, that indicate the given number is an odd, respectively the counter R1 must be incremented by 1. So otherwise if the B not equal to 0, that indicate the given number is even. Correspondingly, you have to increment the R0 registers. Okay, after processing all elements in the array, that is when R2 equal to 0, okay, the program ends. If R2 is not equal to 0, it will segregate the odd and even number. So this is about the working of an 8051 assembly language program. So let us execute the program. Okay, let us execute the program using Keel Microvision 3 software. As usual, I said that for each individual program, you have to create a new folder on the desktop. Okay. So first you have to create a new project and give the suitable name. Already I have created the new folder. This is an experiment number 10 and I will store the project in this file as project 10, project file. So it is not extended with any file type name. Just only you have to give the name. Then save. So whatever previous target project, that will be disappears, and the project workspace will create the target 1. And you have to select the admin. So in that you have to select the required made, that is 89C51 ED2. Once the description comes, under the description window, just to select by clicking OK, then select yes. Okay, after that, once the project folder has been created, next you have to type the program. So by selecting the file toolbar, and you have to type the program here, where you are going to write the program to separate even and the odd numbers. Okay, to count the even and here already I have written the program. So just I will copy it, whatever the logic I have I have explained same thing. Okay, here copy and then paste it. I told that R1 will hold the, okay, R0 will hold the number of even number and R1 will hold the count of an odd number, and this assembly language instruction are case insensitive. You can use the both the letter, even you can use the capital letter or small letter. Okay, here this should be, if the given number is odd, update the odd count. The whatever the logic you have used, okay, thus for the segregation of positive and negative numbers, same logic here. Instead of checking the MSB bit, we are checking the LSB bit. Only we are changing the RRC to RLC. That is the difference. Okay, and this should be RRC. Okay, so RRC. So that will check the whatever the program I have typed for the segregation of positive and negative number. Same logic is used, only I have to make change of the rotate instruction. Instead of checking the MSB bit, you have to check the LSB bit. Once the file has been typed, store it under the folder experiment 10 with the program with the file name as PR10 with the extension of .asm. Okay, .asm is very, very important, and you have to save this file wherever you have stored the project file for the corresponding experiment. Now it is on the desktop. You have to get that file, source file, into the IDE, the integration development environment. So just write source group, add the file source group, select the source file. It is in ASM. So pr10.asm, add it. Then once this added, just to close that file case, so you will get the source file under the source group folder. Afterwards, you have to check whether any error has been generated or created during the typing of the program. So for that, you go to project and select build target. Once you click on build target, you have to confirm whether you are getting the 0 errors or not. If 0 errors are getting, then you can proceed to next step. Otherwise, you have to rectify the error. Same step has to be repeated. Once the error has been corrected, save it and again build the target. Once the program is error free, then start executing the program. That is debug, start and stop run. So it will ask whether we will run the code with the size of 2K evaluation version. Yes, you can select yes. Then what is the memory address? We have used 90,000 9,000 memory location. Since it is an external memory, you have to use X. Just X colon 0 X. What is the starting address? 9,000. So how many number you have to give? Any 7 number. So let us I give 0, 2, 3, then 4, 4, 7, 6, 5, 1, 2, 3, 4, 5, 6, then 9. So in this array it consists of total 7 elements, out of which how many numbers are even? 2, 4, 6. Totally there are 3 numbers are even and odd number are 3, 7, 5, 9. So 4 numbers are odd number. So after executing your program, R0 should contain the 3 total count of an even number. R1 should hold the odd number. So here, in order to execute, go to debug tab, then run it. So once you run the program, it will not update the register. Once you stop running, you will get the odd number, even number count, that is 4 and 3. Okay. So total number R0 is storing here odd number and reverse, and R1 is storing the even number. Okay. So this is about the, here if the given number, this is about the segregation of an odd and even number. Thank you for watching.